Hello, everybody. Welcome to today's webinar, The Reimagined Mine. My name is Sam Sakasiris. I'm the National Membership Team Leader at Osmine, and I'll be your host today. Before we begin, on behalf of Osmine, all of today's presenting companies, I'd like to acknowledge that I'm hosting this webinar from the lands of the Whadjuk Noongar people. We acknowledge the traditional custodians of the various lands on which we all meet today and recognise the Aboriginal and Torres Strait Islander people attending this webinar. The mining sector is undergoing a significant transformation driven by automation, digital systems, AI, and sustainability. The mining innovation across the lifecycle webinar series will dive into the mining lifecycle from smarter exploration techniques to digital mine planning, intelligent operations, advanced processing, and mine closure. This session will explore the breakthrough technologies redefining the industry from AI and machine learning to integrated digital ecosystems. The agenda for today's webinar. I'm joined by 5 industry-leading member companies sharing their breakthrough technologies that are redefining the industry from AI and machine learning to integrated digital ecosystems. Joining us to share their expertise today is Kerry Doherty, Sales and Legal Specialist from Universal Field Robots, Ian Jones, Head of Product from CommitWorks, Peter McPherson, Director of Engineering, MRA Automation, and finally, Carlos Wang, Marketing and Sales Manager, and Ricky Lin, Sales Director of Mining Technologies at Nuctech. The format of the webinar will include a short presentation by each of the presenters, followed by a Q&A session. If you do have questions for any of the presenters during the webinar, please type them into the Q&A box at the bottom of your screen. If your question is directed to a specific presenter, please note their name in your question. This webinar is being recorded and will be shared with all registered attendees. That concludes the welcome and introductions. So without further ado, I'd like to welcome our first presenter, Kerry Doherty.
Thank you very much, Sam. I'll just make sure I can get my slide control working. And there we go. All right. Thank you, Sam. Thank you so much to Osmine for giving me the opportunity to speak and speak on something that I think is really interesting and definitely in line with what we're doing here at Universal Robots, which is reimagining the mine. So as Sam mentioned, my name's Kerry Doherty. I'm from Universal Field Robots. We're a Sandvik company. We're Brisbane based and we're focused on delivering OEM agnostic automation and robotics into mines all around the world. So I'm really excited to talk and help open today's webinar on the Reimagined Mine because I think the topic of zero entry mining is one of the clearest ways that we can test on how seriously as an industry we are to reimagine mining. So if you aren't familiar with the concept of zero entry mining, I'm talking about a system of mining where people are no longer needed to be physically present in the mine. So that immediately makes us think of robotics and automation, but it does go a lot deeper than that. And it certainly doesn't mean removing people from mining. It means changing how we work in order to move people away from unnecessary exposure, moving people into safer, higher value roles, such as supervising, control, maintenance, optimizing, planning, and intervention. So it's about taking people out of the loop of mining and putting them on the loop. And to me, the reimagined mine is not just a mine with newer machines, better dashboards, and more data, although it will be all of those things. It's really a mine where we challenge some of the oldest assumptions in mining. One of those assumptions is that people need to go where the work is. Zero entry mining really challenges that assumption. We really want to start thinking about what ways we can physically remove people unless there's a very required reason for them to be there. So that's obviously a very big goal. It's not a new concept, and it has proven to be a very difficult goal to achieve. And it certainly won't be achieved by one machine, one manufacturer, one software platform acting alone. It's going to require many different systems working together. So that's going to be fleets of autonomous systems, sensors, communication, safety systems, planning tools, control platforms, site workflows. All of these things are going to need to be looked at from end to end. We can't be looking at them as individual components to a mine. And so that's why, to me, where I work at Universal Field Robots, why I think OEM agnostic automation is really important. So that's automation which works across a fleet, regardless of the build or the brand of the machine. Because ultimately, most mines are not clean sheet designs. They're mixed fleet, they're brownfield environments with equipment from different OEMs, bought at different times for very different jobs. And so if zero entry is going to progress in the mines that we actually operate today, autonomy has to work within that reality. It has to start with a task in mind, not just the badge on the machine. And so that's the idea I want to explore today, is how zero entry mining can be achieved, how we can move from a long-term vision into practical steps by creating pockets of automation in real life mining environments. So I've touched briefly on what zero entry mining is. It can be this very far-fetched goal of not a single person is in the mine, as if we're mining on the moon. That's how we talk about it very conceptually, but we need to talk about it practically. And for us, that's it's chunking it down into smaller pieces, and it begs the question: is it still worth pursuing? So the safety case is obvious. If you don't have people in the hazardous zone, you completely remove the exposure to risk to those workers. When it comes to safety risk mitigation, elimination is always the best option. And that's really the only way that we can truly guarantee the safety of the people in our industry. But zero entry has to be more than just a safety idea to gain traction in the market. And it argues that human presence in itself is an operating constraint, especially within underground mines. So having people in mines creates travel time, clearance requirements, re-entry procedures, delays due to shift change, and it also has very large costs associated with being able to support human life underground. So refuge requirements, ventilation, in some of our deeper, hotter mines, refrigeration, as well as all of the access and egress requirements. So that's a huge cost. Some estimates will put ventilation alone at a third of the price of the construction of a mine, which is enormous. So is zero entry mining worth it? We would argue yes. And the value case is not linear. So this is a graph provided by the Global Mining Guidelines Group, who have been really putting a lot of work into defining what zero entry mining can look like and what the value case is in the long term. So early automation, integration, fleet management systems will create this small incremental value. And I say small, it's probably quite significant over time. And that's what we're seeing at the moment. But we reach a sort of breaking point where when the last person is removed from a production area, we can stop designing the mine around keeping humans alive, and we see tremendous increase in, or rather decrease in infrastructure costs. So there's a really large value to be gained here at that first break point. And then that second break point comes when we start really looking at how we can redesign the entire process end to end, with humans, not being the focus of the mining process. So the strategy of zero entry, it's not about only making mines safer. It's really about changing what tomorrow's mine can become. So it sounds it sounds beneficial. It sounds promising. So why has this not happened at scale? I don't think it'll be a surprise to anyone that mining is risk averse. It is also a hugely complex production. And shifts to date have been really driven by workplace safety and chasing small incremental boosts in productivity. So we're seeing a slow shift, and we're seeing small pockets of automation develop across the world. But despite these impressive examples of implementation, we're still a long way off a mine that can operate without having a human enter it. So today, a fleet of trucks might be autonomous, but people are still going to need to enter for inspection, refueling, recovery, maintenance, and exception handling. A drill might be automated, but the survey, the charging, the setup of the machine, ground support, and other related production tasks are still going to require people to enter. So we want to try to automate tasks, but ultimately mines still require humans, and there's just this plethora of secondary tasks which surround the automated tasks that we see today. So we need to really examine the procedures and the equipment and all the processes that sit around this in order to even attempt a zero entry approach. This is obviously very difficult for a brownfield site to unwind. And that's why we need to look more at small pockets, more how can we make one area of the mine autonomous? How can we have zero entry areas within an entire mine? That's where we see is sort of the starting point, where the beachhead of this concept could really land. So in terms of that, you end up with a lot of complicated systems sitting across a site, and we end up with a fleet of machines on site, which are bought from separate OEMs. They operate on separate systems. They interact differently, and there's separate processes related to each of them. So this is where we see a lot of difficulty, at least within the robotics space and the automation space, of getting traction. So UFR's solution is to really focus on OEM agnostic automation. So with most mines running mixed fleets, we're operating not like a catalog that works flawlessly like the OEM promises. Most mines operate like this history book. The zero entry pathway really only works. Working inside one ecosystem is going to be very limited. And we need to be looking at automation which can spread across any OEM, any on-site system. So there's a lot more integration required to make that possibility. And I'll be talking later on about how UFR is tackling some of those tasks. Ultimately, we need to be looking at the task across the entire process, not just the badge on a machine, and looking at existing assets, current workflows, the exposure, and the production constraints that apply. Then we can start looking at single moments or processes where we are able to start removing people from that safety hazard. So that's the bridge between where we operate today and the zero entry mine that we design in the future. For existing mines, the practical path is not going to be a full redesign on day one. Like I mentioned, we really want to focus on creating pockets of zero entry. So a pocket could be one haulage route, where there is just a strict rule that there is no one is allowed to enter that space at any point. So it allows us to run that area with an autonomous exclusion zone, allowing operation to happen 24/7, non-stop. It could be inspections. It could be water cannon operation, refueling, logistics, or support tasks. Anything that repeatedly pulls people into a production environment. So it's those white spots that we need to be looking at. So assessing the tasks that pull people into a production zone and rethinking, one, do they need to be there? And two, how can we redesign the entire process, not just that one task? Sorry, not just that one piece of equipment or that one person's job. By creating these small pockets, what we're doing is three things. One, we immediately reduce exposure for workers. Two, we create increased operational value by increasing periods of operation, allowing for optimization through autonomous the vast amount of data we can pull from autonomous machines. And three, it creates a bit of a social proof that the technology is able to work, and the operating model is able to work. The technology, in my opinion, and I'm biased, obviously I work at a robotic company and I'm trying to sell robotics, but the technology is there to achieve this task. But the old methods of operating are not going to be the correct fit. So we need to start showing customers, we need to start working with customers, and proving that these new approaches to mining are in fact a reality. So some quick examples of how UFR is currently achieving small pockets of zero entry mining. We have been working with Goldfields quite closely at their Granny Smith mine, where we've been automating their MT65 haul trucks. So the opportunity was not simply to automate the truck, take a driver out, put them in a remote operations station. It was really about how can we also prove and how we can prove a extended operating period. So without designing haul trucks around people, we can now operate them 24/7 because there is no shift change. There is no requirement to stop the operation of the trucks. So we have a fully autonomous drive there, and now the trucks don't stop running during shift change. So we've seen a significant increase in the utilization of the trucks and about a 15 or up to 15% on a good day of materials hauled. So I think this is a good example of the zero entry thinking and practice. We obviously want to keep people safe, and removing drivers from underground haulage routes is certainly a great way to do that, and eliminate any risk of human vehicle interaction. But we're really looking at, well, if people weren't there, how could we improve the process? And so this is using current equipment. It's creating the safety value, extended utilization at the same time. So it's really not a theoretical case in this underground mine. It's a practical pocket of zero entry. So we haven't had to redesign the entire mine. We've just taken one discrete process and we've identified, is it possible to make an autonomous exclusion zone? In this case, yes, absolutely it is. I'm aware that I'm running a little bit tight on time, but I'll quickly just mention our auto prep product as well. So for the process of blast hole preparation, so post drilling, but before blasting, there's a huge amount of exposure for humans, particularly with, depending on the type of mine, with dust particles and rock falls. We attempt to we've identified this as another really good beachhead where we can create an autonomous exclusion zone and be operating a bespoke a robotic arm that is able to survey, drive into a drive, survey, and identify and then clean production blast holes in advance of them being charged. So I guess in closing, zero entry mining isn't just a slogan anymore. It's not a sudden leap to an empty mine. It's going to be a long journey, and we're already seeing that. So we are proposing staged transitions towards mining systems where people no longer to enter hazardous production zones for routine work. It's absolutely worth pursuing because ultimately it improves safety, and it also has huge upsides in terms of improving utilization caused by people-related delays. It will be able to reduce the cost of support infrastructure, addresses labor constraints, and having to send people to very remote locations to work. It has the ability to improve consistency and changes the economics of much harder to mine ore bodies and deeper and hotter mines. So the blockers are real. Most mine sites are currently, a brown field. Most fleets are going to be mixed, and most processes are designed around people. So if we can start delivering automation in small pockets and grow and making sure we're taking into account the interconnected systems that are in play, this is exactly how we're going to start seeing automation pushing underground mining to further and further down this zero entry journey. So let's just focus on one task at a time, one production window, one workflow. And so this is where UFR, as part of Sandberg, is focused. Practical autonomy for real mining environments and using existing assets where possible, helping customers move from isolated robotics towards a safer, more productive, more flexible mining systems. And I think that's the path towards zero entry. So thank you very much, Osmine, for giving me a couple of minutes to talk about this, and I look forward to all the other presentations. And if you've got any questions, feel free to leave them in the chat. Otherwise, I've got my details here, and feel free to send me an email and get in contact. So thank you very much.
Thanks very much, Kerry. Interesting to see, the zero entry mine coming along, and good to see Goldfields getting on board with putting that into practice. Next up, I'd like to welcome Ian Jones.
Hello, my name is Ian Jones, and I am the head of product for CommitWorks. We've joined today to discuss with Osmine the Reimagined Mine, because we believe there is a real conversation that needs to occur about how mining activity is tracked, conformance to plan, and the impact of artificial intelligence on that. CommitWorks, the company, has been around since 2011. We started as a company that took an idea from consultancy and turned that into a product. That product is highly motivated around operational excellence, and that is taking the operational plan and executing the plan in the correct way. One of the key areas that we support in the mining environment is short interval control. Recently, we've been acquired by Doherty, and as part of the Doherty family, we look forward to a future of integrating their mining products, their fleet management solutions, and our operational planning solution. So what is the problem that we are trying to address? The problem is that the conformance to plan measures that we take for granted on mine sites, they lack context. They tend to be driven by the engineering group and not by the impact of the operations on those. So conformance to plan is tracking the right work in the right location and delivering the required amounts, very much engineering or mining tasks. Conformance to plan doesn't track the impact of the decisions that are made by the operational team, why targets are missed, and what can be done better next time. So the sort of questions that we will see asked of AI are, did we hit our mining targets? What is the impact of the decisions we made on reaching our mining targets? And what caused us to miss those targets? If we look into the future and what potentially the mine of the future looks like, we see AI becoming a part of the conversation at shift handovers, at weekly planning meetings, and at daily planning meetings. So the graphic that we see here is fictional, of course. We use ChatGPT, but we fed into it that we were going to bring AI to the table, that we will be looking at mine plans on paper, that we were looking at whiteboards, that we were looking at or recording the decision processes being made. And this is where we see AI needs to expand to be able to encounter this. So what are some real world scenarios that we may look at that our tool can actually help you with? The first is things like object detection events and their effect on planned work. So something happens that is out of the ordinary that affects the way that we deliver the work that we plan. So for example, putting a large rock falling onto the back of a haul truck on an automated circuit, it stops all of the equipment operating on that circuit. And we need to understand where that rock came from and what was the impact of that on us delivering our targets. Another example of that is whether work from another department interrupts planned work. In an underground mine, where we know visibility is limited, the idea of dispatching a jumbo into a heading where the surveyor has yet to finish their work has a major impact on the ability of the mine to hit the plan that it's put in place. So CommitWorks see there are some key gaps in the way that we do things at the moment. We know that the mine planning solutions we use on sites are very, very mature. They're highly engineering focused, and they're focused on delivering the mining activities. that happen on that mine site. But to make that work properly, we also need to know the resourcing we have available. And there are two key conversations that need to be had about that. The first is, where do we understand the operators or the people that we have on site for that shift for each process, so that we can make sure those resources are adequately used or utilized. The other part of that conversation is what equipment do we have available. And one of the key drivers for that is the planned maintenance schedule that is coming forward from tools such as SAP, from Maximo, sorry. So the reason for this is that if we don't have equipment available, we are not going to be able to achieve the mining activities. On the other end of that spectrum, we have tools such as your fleet management solutions, which take data off the equipment and they report back to us how the work was executed. There are other tools that work very much in this space as well. One of those tools, for example, is PitRam, where we use radio call-up to actually update the progress on the site. Either one of those tools will give us the progress, but what we're missing is the operational planning and execution piece, the piece that sits in the middle. And this is the gap that's CommitWorks see as a real issue for getting the maximum value out of our AI solutions. What the operation planning and execution stack does is it takes data from the beginning of the weekly planning process and daily planning processes, and it then uses that data to inform the tasks that supervisors then take into the field and execute with the resources they have available. If we don't understand the decision-making that goes behind that, it is nearly impossible for us to ask the questions of AI that will give us considered and valuable information from the AI tool. So capturing the data that currently goes onto whiteboards, that's recorded in supervisors' notepads, just recorded in the actual meetings themselves, is a key part of the gap that CommitWorks fills in this space. So our value is to give frontline leaders the most day-to-day operations, the plans and discussions that they need to track. This is done in a number of ways. So the first part is actually just understanding what the critical path items are, the mining activities that have to be done. But then we also add into that all of the enabling activities, the work that supports that being delivered. And enabling activities can have a major impact on the way that you deliver your plan. So part of the CommitWorks focus is making sure that we understand all of the work, not just the work that's coming from the mine plan. Once you have all that information available and you resource that properly, you're going to have a plan that you can rely upon, that you can report against, and it's going to give you far greater control of that compliance to plan messaging. We already see some of this be in operation with our fleet management solutions, and the fleet management solutions are also becoming very much mature products. They're products that have been driven very much by the automation of fleets. And what we're able to do is then build customized time usage models based upon the data that the mining operations see as most important. So we've built the time usage model, and then we're able to report against delays. We're able to track where downtimes are occurring, and we're able to put in place resolutions to those areas. So if we are to get data maturity, we need to actually empower the people making those decisions. So the starting point for that is bringing the short-term mine plan into the weekly mine plan, where the operations team have input into how that plan will be executed. We add the maintenance plan to understand the resources that we have available. And then we use a scheduling role to build out the enabling tasks. Once you have that information available, you're able to manage the crews and equipment through key meetings, capture a summary of the delays that have interrupted the plan, and introduce a way to capture the actual delays and their impacts. The pictures that you see on the screen here are taken from different websites where we did a search for the line-out process at the operational planning level. And you can see here, we've got people looking at maps, we've got people looking at screens, we've got discussions with the employees that are going to do that work. If we get this right, and we're able to build out tracking of not only the tasks, but the delays, what we're going to end up with is being able to build an execution model that allows us to use similar concepts to what we see in time usage, but we now see those in the fleet management space. So the CommitWorks product is designed to enable you to do that. But it doesn't matter what product you use, as long as you're making sure that you are capturing all of the information that's required to support the decisions that are made on shift. If you'd like to see more discussion on this, I've written a number of papers, and those papers are available on LinkedIn. And if you'd like to scan the QR code that's on the screen, that will take you to those papers, and you'll be able to see what it is that we have been talking to the industry about and trying to lead conversations. So with that, I'd like to wrap up my component of this. I'd like to thank you for listening to us talk about what you can do with your data to make it better suited to AI. And I wish you all the best in achieving your goals with the AI platform. So thank you for that.
Thank you very much, Ian. Interesting to see how AI is helping with data process on the website. Thank you very much. Next, I'd like to welcome Peter McPherson from MRA.
Thanks, Sam. Yeah, thank you everyone for joining today's seminar. Firstly, just an introduction to myself. So my name is Peter McPherson. So I'm the Director of Engineering and of the now bulk automation technology team. So previously MRA, we've been acquired by Metso as of February this year. So just currently being integrated into the Metso organisation. I was a major shareholder of MRA Automation, and predominantly the last 12 months been looking at that commercial growth of the organisation and sales and we're background in electrical engineering and automation, so heavily involved in stockyard automation, mobile machinery, and the way. And that's what today's presentation is about, is how that is moving on with the new technology to the market. What are some new innovative technologies being introduced to that stockyard space? So just a little bit about our business and what we do. So we're located in Newcastle, and we have around 60 engineers, and that team is heavily focused on bulk materials handling and technology. We have two main divisions, one being traditional electrical automation services, where we perform PLC, SCADA, electrical design for mobile machinery. And it's from that technology base, that domain knowledge, is where we invested heavily in R&D and developed what we call our AXO 33 product, which is a smart automation product suite that adds to the control system rather than replacing it. And that's what we'll speak about in the next couple of slides in today's presentation. So what are we achieving with this AXO 33 product? And it's all about being able to visualize and track material from end to end across the whole value chain of pit to port. So from stockyards in the mine onto maybe rail transport to a port, or it could just be a direct mine to port without that rail network, into stockyards at port facilities, then into vessels typically. And that's the usual Australian pit to port value chain. But then, of course, there's the opposite in importing countries, where you're bringing it in via maybe ship unloaders into a stockyard and through. And that's so our technology can work in both those value chains, whether it's exporting, like we're used to in the Australian market, or whether that's importing in some Asian markets or others throughout the world. So what are the products that we have? We have our train suite. So we're looking at how can we digitalize what is happening at a train loadout, for example, or an unloading facility. So being able to build a digital twin of that process provides smarter information to the control system. Not replacing the control system is that key point there. So it may be where the beginning of the wagon is, or where the end of the wagon is, or what volume of material is inside the wagon at a real time in that process. So then we can make those smart decisions. So our software's operated on more than 17 million wagons. Some of those has been semi-automation, some of those has been fully automated. Our stockyards, which we have a little bit of a video coming up in a moment of that digital twin in action. similar concept, building a digital twin. What is in front of the, you can see the picture of a bucket wheel reclaimer on the right-hand side there. What does the stockpile look like in real time? What is the quality of the material? How much material is there? Where should the machine turn around? Is there going to be an overload? All of that information can be given to the control system, where traditionally that was done by an operator using their eyes, looking out the window, controlling the machine. Then the first wave of automation was introduced to stockyards, where a lot of assumptions were made. It works brilliantly for a uniform stockpile where the material isn't being moved by dozers, hasn't been impacted by weather, it isn't crumbling and causing avalanches. But having a real-time digital twin, you can start to remove all of those assumptions and make more advanced decisions, and hence improving throughput, which you'll see in a moment. So our system's worked on over 2.65 billion tonnes of material, and that's been across coal, iron ore, bauxite, potash. So it's applicable to any type of bulk material. Then on to the AXO 33 ship solution, very similar to the others. It's all about building a digital twin of what's happening in front of the ship loader or unloader, making sure you don't run into the vessel, being able to visualize what is in the hatch of the vessel, and making smarter decisions. Once again, you can see the maturity there of that solution as well. What we have now is a brief video that just shows that digital twin in action of a stockyard. This is of a coal export facility in New South Wales, Australia. And you can see that bucket wheel reclaimer from some drone footage and what the digital twin is representing. So we build this in a gaming engine that is a full pan tilt zoom style environment. The operator can move around and see exactly what is happening in that facility at any point in time. And we're using laser scanners to update that profile, which was those colored rainbows you could see. And then we start to overlay key information such as machine turnaround points or number of tons on the ground. So it's a very interactive digital twin of what is happening in the stockyard. And that's where a lot of our customers struggle, is they may be using lots of spreadsheets, or they may just be making those assumptions as mentioned before. And for that reason, the stockyard becomes the bottleneck of the whole pit to port process. So being able to make these advanced decisions, you can then start to reduce that bottleneck and hopefully remove it from the value chain rather than just pushing it to another area. So a bit of a case study and some value. What is the value of our product over the next couple of slides? So this was a WA stockyard case study. So an iron ore based facility in WA were able to increase their throughput by 4.3%. So the value speaks for itself there. If you can increase throughput by that type of percentage, then it's an easy decision to roll out this type of technology. But obviously, some places it's not just about throughput. It may be about asset life, for example, which is the next example here. So one facility we did in North America, they were getting over 270 bucket wheel overloads per month. So being able to introduce our technology, we're able to reduce that down to 6. So that may allow to get a couple of additional years out of machinery that may be end of life or may prevent outages or downtime. So it's a very, very powerful tool, not just in increasing throughput, but also in asset protection. And then there's also a value case there on the grade tracking as well, being able to predict what grade you are going to achieve when reclaiming a stockpile, so to ensure you meet the contractual requirements. So also some value proposition there on the AXO 33 ship solution. So being able to support the operator. Typically, these are manually operated machines. So being able to support the operator, ensure there's no collisions, and then also reducing machine stress. So very similar proposition to the stockyards. Onto trains, so similar story, being able to increase throughput and also in the specific for Train unloading and loading is also being able to reduce tip times and load times. So being able to, it may mean an extra train per month could be passed through the facility. And demanning operations is a important one in this scenario too. It can be a hazardous environment, similar to the stockyard space. Having an operator on the end of a boom or in a cabin in a line of fire in these type of plants, it's very useful to be able to move them to maybe a remote operating center or remove them from the system altogether. Then inventory management. So being able to track then end to end when you have technology in the stockyard, in the trains, once again in the stockyards, in the port and in the vessels, you can do that end-to-end forecasting, knowing what material is where, when is it going to arrive, is there going to be any clashes? It's a very powerful tool. So that's all I had for today, just a very brief introduction of our technology, which is now under the Metso banner, and where it can benefit the whole pit to port value chain. Thank you for your time.
Thank you so much, Peter. Interesting to see the AI, the automation being used so well with it, and the digital twin, which is really becoming effective on those mine sites. Finally, the last two speakers, it's my pleasure to welcome Carlos Wang and Ricky Lin.
Hello, everyone. It's great to join today's webinar. My name is Ricky Lin, Sales Director for the mining sector at Nuctech. Today, I'll introduce how Nuctech sorting and rapid analysis system helping mining operator reduce waste, unlock plant capacity, improve resource efficiency, and make better decisions. First, I'll briefly introduce Nuctech and our mining background. Nuctech was founded in 1997. We have developed deep experience in X-ray and other detection products. So in the mining sector, our technology includes X-ray transmission, which we also call XRT, LIPS, PGNA, PhotoNC, and XRF. So regarding our market in Australia, some of you may know that PhotoNC technology in the gold analysis is now replacing the fire assay in commercial labs. This product was co-developed by Nuctech and Chrysos. Right now, there are 19 units running in Australia. We have an after-sales service team, a branch office, and a spare warehouse in Sydney. And a mining agent in Brisbane called R5. Today we'll focus on XRT and LIPS. So XRT sorting. XRT sorting, which we also call the sensor-based sorting. XRT sorting use metallic minerals like gold, copper, tin, tungsten, lead, zinc, silver, etc. Non-metallic minerals like phosphate, fluorite, coal, and coal gang. As long as the particles are larger than 5 mil, the valuable rock and the waste rock show differences. The working principle for the machine is very straightforward. The vibrating feeder will separate the ore by one layer on the belt, and the X-ray and the visible light will detect the ore particle by particle. And then in the end of the belt, the AI program will identify which particle is concentrated, which particle is waste rock. So in the end of the belt, the high pressed air will blow the concentrate or blow the waste rock. So in the end of the belt, the material will separate. The key point is that XRT sorting works before grinding and flotation or leaching. Instead of sending all the material into the mill, we can reject the waste earlier. So XRT sorting could create the value in this scenario. First is the low-grade ROM ore by upgrading feed grade and plant capacity. Second is waste dumps or marginal stockpiles by turning them into economic feed. Third, remote mines by reducing transport costs from pit to plant. For arid projects by cutting water and regrant cost. Five, the companies seeking quick cash flow by upgrading concentrate cells. So let's look at two of metal ore sorting examples. The first is the gold ore sorting project. This site lies on a remote plateau about 3,000 meters with harsh environmental conditions and water shortage. This project, gold is associated with bronze iron. The raw ore grade is very low, only 0.23 gram per ton, so directly processing is not possible. We build a sorting system, achieve concentrate grade 1.4 gram per ton, yield is 10%, recovery is 62%. This project annual benefit is around 1.4 million US dollar, and the payback period is about 7 months. The second example is the zinc project. This customer has a zinc mine. The raw ore grade is below 3.4, and flotation cannot process it directly. After XRT sorting, zinc concentrate reached 9.9% with 82% of recovery. So now concentrate can meet the flotation standard. The annual benefit exceeds 7 million US dollar with a payback period only about 3 months. So let's look at two non-metallic projects, coal and phosphate and coal gang. For this phosphate project, XRT sorting helps customer reduce downstream processing pressure and improve the value of the feed going into flotation. Our machine processes 10 to 50 mil ore. It rejects waste and the concentrate enters the flotation plant. The coal gang sorting project customer rejects a large quantity of gang from a heavy medium coal plant. Traditionally, this material goes to disposal and generates processing fees, but it contains 30 to 40 kaolin, which means there is a hidden value inside the waste. We sold 50 to 300 mil gang. The customer can reduce disposal costs, recover kaolin, and create additional economic value. So in other words, XRT sorting helps turn waste into resources. Now I'd like to move from sorting to analyze, and this will introduced by my colleague Carlos.
Hello everyone, I'm Carlos Wang, and I will introduce the rest of our analytical techniques. So LIBS, or laser-induced breakdown spectroscopy, is a faster elemental analysis technique, which outputs results in seconds. Every element has a unique spectral signature, so LIBS can identify nearly all elements on the periodic table, including both heavy elements and tricky light elements like hydrogen, lithium, and beryllium. Most importantly, it produces no ionizing radiation, so no actual radiation protection is needed. Compared to XRF, LIBS excels at light element detection and needs only simple sample preparation. So if XRT helps us make better physical separation decisions, LIBS helps us make faster analytical decisions. Nuctech provides a full lineup of LIBS products for diverse mining scenarios. We have handheld units for on-site ore grade and type identification, benchtop analyzer for laboratories and research institutes, industrial in-situ systems that seamlessly connect to production lines for real-time quality monitoring for coal, iron, lithium ores, and more. Powered by our proprietary self-learning algorithm, our analyzer keeps improving accuracy with more sample tests. This reliable, faster analysis could bring solid value to production and help the mine owners make data-driven decisions more efficiently. Now please watch a short video. Our industrial LIPS system fully automates sample feeding, preparation, testing, and the result output, finishing all steps within just 1 minute. Okay. So in order to provide more convenient and efficient analysis solution, we developed an all-in-one container laboratory based on LIPS. Hosted in a standard 40-foot container, it can achieve a one-stop real-time analysis from the input of raw ore to the output of data report. The whole process, including crushing, splitting, drying, and testing, takes only within 30 minutes. Its precision can fully replace traditional third-party lab tests. Easy to deploy in remote mines. It only needs one operator for daily work, cutting 2 to 3 traditional lab staff and greatly reducing operating costs. The investment payback period is less than 2 years. We are certain this will be a game changer in the mining analysis sector. Okay, so that's all for today. Thank you for your attention. If you are interested in our solutions, please feel free to contact us and follow our LinkedIn website for more information. Thank you.
Thank you very much, Carlos and Ricky. Interesting presentation there. Look, that's the end of the formal presentation, but it's now time for the audience Q&A. If you haven't already sent in a question, please use the Q&A button at the bottom of your screen, and I'll get started with the questions now. The first one is for CommitWorks. Does your fleet management software do comparison of electric to engine-powered vehicles?
Thanks, Sam. The answer to that at the moment is no.
Okay.
Happy to take that offline and have some further conversations around use cases and where we might fit into that. Whoever asked the question, though, if you'd like to reach out.
Thank you for that. This one is for Kerry. For sites that are already operating, is zero entry mining realistic, or does it only make sense for new mines?
I mean, it's obviously a lot easier to fit into a green site, which can make a whole stack of decisions, from the outset around their infrastructure and remote operations and communications within the site. So, I mean, for long-term visions, absolutely, greenfield sites are where we will see the biggest benefits for zero entry mining. But it doesn't mean that we can't consider brownfield sites. And like I said in the presentation, it's really just around creating or identifying these areas where you can create autonomous exclusion zones and creating these pockets of zero entry. So there's shift change is an obvious one where we can the mine will be innately free of people. So if you've got the right automation in place, you're no longer losing an hour a day to shift change or 2 hours a day to shift change, which over a year ends up being pushing between 5 and 10% of your potential operating time. So it's there are still really significant gains that can be made with current sites. But obviously those long-term benefits I spoke of, those sort of predicted benefits I talked about, they're going to be for sites which have the confidence to move forward with much more, technologically informed sites. So they've got to be greenfield for those long term, but in the short term, absolutely, there's still massive benefits to be gained.
Thank you, Kerry. Our next question I have is for Peter McPherson. Can this software work with any OEM's machines?
Thanks, Sam. In short, our AXO 33 product is designed to work with any type of machine, and not just any OEM's machine, but also any age of machine as well. Whether that's some of our projects have been for machines that have been over 25 years. They may need a PLC upgrade and a drives upgrade as a part of the project. And some are greenfield projects, so we can go all the way from quite old to new, and any OEM's machine is our system is applicable to.
Thank you very much. This one's for Carlos and Ricky. Does Nuctech offer any analyzer for live oil analysis?
Okay, so for our LIPS technology, we can detect based on the element. So I don't know if you want to analyze the certain elements in the oil. So if that's the problems, we can probably produce a sample container which we can vaporize the oil, and we can detect the certain element. But right now, our analyzer is mainly focused in the mine sector. So yeah, if you can ask our with your specific requirement, and we can customize for your requirement.
Thank you so much. Next question is for Lamise at CommitWorks. What does the data mine acquisition mean for CommitWorks and for site ops?
So the acquisition's pretty new. We're all really excited about it. What it does is open a lot of doors for our customers. So we have a broader network, we have more experience, a lot more backing, and nothing changes day to day for current customers. We just have a broader footprint and more help across the globe now if anyone wants to find out more about site ops.
Thank you so much. Kerry, next question is for you. What makes OEM agnostic autonomy important for the zero entry journey?
Yeah, so this is something that our parent company Sandvik is talking quite a lot about. It's might seem back to front that an OEM is talking about OEM agnostic automation, but they really see this and they hear this all the time from their customers that they don't want to commit to a single OEM. There's just not one provider that is providing the best equipment across the board for every task. So Sandvik themselves recognize that, and that was a big part as to why they've acquired UFR to add to their already impressive auto mine system. So it's really important for that reason that sites, no matter how good an OEM is, they're always going to have a mixed fleet, and they're always going to have legacy infrastructure and processes on site. So we can't just be looking at the machine brand. We need to be looking at the task that needs to happen, and how we can actually work with the site to implement automation across that site, regardless of what they've got there. So we need to be looking at automation which is able to talk to not only the machines themselves, but also the traffic management systems, the safety systems that exist on site. And regardless of the brand, that shouldn't preclude a miner or a contractor from gaining the benefits of automation.
Thank you very much, Kerry. Next question is for Peter. So what's the biggest point of difference of the AXO 33 offering compared to its competitors?
Thanks, Sam. I think the biggest point of difference there is around the people who have developed the software. So we are a bulk automation materials handling business. So we've worked on so many stackers, reclaimers, ship loaders, developing PLC and SCADA solutions, and then we've developed this software product rather than a number of competitors have come out of spin outs of universities or other technology style businesses that have approached it from a more generic software level where it's replacing the control system. So it ends up being a black box on site that then customers can't maintain support. They're tied to that vendor. We're having a PLC-centric solution where we're giving smarter information to the control system rather than replacing it. Is that value? So that's our key point of difference.
Thanks very much. I've got time for one more question. Carlos and Ricky, how can I determine if my ore is suitable for XRT sorting and what grade can be achieved through sorting?
Thank you. So first, the clients need to look at the raw material by eye to see if there's a difference between concentrate and waste rock, and then pick up by hands. And we will do we call it a manual separation. And then you can send the manual pick the samples to the laboratory, and after the test results come out, we'll see the grade difference. So normally the heavy element performance is better than the light elements. Now Nuctech provide the free test service to the clients. We are happy to take the responsibility of the transportation of the mineral from Australia or whatever it is back to China, and we'll do the test and then give you the report.
Thank you very much. That's all the time we have for questions, but thank you all very much for submitting those, and thank you for those answers. Look, if you enjoyed this webinar, you can review all 6 parts of this series on our YouTube channel. Look, thank you to everybody who's attended. We look forward to welcoming you to another offline webinar in the future. Finally, I'd just like to thank all of our presenters, Kerry, Ian, Peter, Carlos and Ricky, for sharing your expertise with us today. Thank you, everyone, and enjoy the rest of your day.